In this video, I am going to go over questions that you will see, similar questions that you will see on the GED Math test that relate to geometry. So these will be geometry questions. There's 5 of them. Let's jump into the first question. It says question 1. A rectangle has an area of 54 square inches and a length of 6 inches. What is the width in inches of the rectangle? So let's highlight the final question and read it right here. You actually have access to an electronic highlighter on the GED test. So this is the question. What is the width in inches of the rectangle? So that's what these answer choices represent. These represent the width of the rectangle in inches. So this means 9 inches, but it represents the width. And this, for example, D represents a width of 48 inches. So it's important to highlight that final question so you know what your answer choices represent. Now we're dealing with a rectangle, so let me just kind of sketch a rectangle here. Here's one way to sketch a rectangle. And when you're taking the GED Math test, you'll have a formula sheet. You'll look for area of rectangle, and this is what's going to pop up. A equals LW, which really means the area, A represents area, equals L, the length, times the width, W. So it just means to find the area of a rectangle, you take the length times the width. Remember, there's a times sign there. So we're going to use this formula to help us. So let's see, the area is the space inside, right? Area is the space inside. Don't get that mixed up with perimeter, which is the distance around. So the area is length times width from right here. And the area in this problem is given. It says right here that the area is 54 square inches. So I'm just going to put area is 54. Now let's label the length and the width. I always call the length my long side and the width my shorter side. That's just how I remember it. If you switch them up, that's okay. So do we know the length? I think we do. Let's see. It says right here, the length is 6 inches right here. So the length here is 6. And we're looking for, let's see, the width, right? What is the width? Well, the formula is telling us to find the area, you take the length times the width. And that gives you the area. So we have the length. So here's what I'm thinking. 6 times what number gives us 54? So let's use our answer choices. Let's start with A. Let's replace the width with 9. So I'll replace the question mark with the 9 right here. I'll put it in a different color. And then I say to myself, does 6 times 9 equal 54? And for this one, you'll probably have access to a calculator. You can just pop up your calculator if you're not sure and go 6 times 9. If it gives you 54, then 9 has to be your answer. And it does. 6 times 9 gives us 54, so A is my answer. And I'm done. Let's go to the next one. It's a little longer. Let's look at this thing. Let's break this down. It says the Wilson family's backyard is a rectangular plot that has a length of 100 feet right here and a width of 80 feet. The family planted a garden with a length and width of 60 feet. So the garden's kind of over here in this area here. It has a length and width of 60 feet. The family planted a lawn in the remaining area of the backyard as shown. So the lawn's going to show up over here. What is the area in square feet of the lawn in the Wilson family's backyard? So again, let's just highlight that final question right here. It's asking us the following. What is the area in square feet of the lawn? So now I know what my answer choices represent. These numbers represent the area of the lawn. Area, lawn. I put it in green because lawns tend to be green. And Now I know what my answer choices represent. For example, this would be an area, A means that the area is 4,400 square feet. So let's see if we can kind of work this out. Now, this whole backyard's a rectangle. They are not showing this part here of the rectangle. Let me just write this in, because this part here that I'm boxing in is the garden right here. Let me get that a little bit better real quick. So because they told us at the beginning of the problem, if you analyze it, that the yard is a rectangle. So they kind of didn't show this piece on the plan, but this piece here is where they planted the garden right here. This is where they planted the garden right here. And the rest of it is the lawn right here in green. So what I really need to do is find the area of the lawn that I shaded in green. Now, if you think about it, if I take the area of the whole backyard and subtract out the garden, just get rid of the garden, I'll be left with the lawn area. So let's actually do that. Let's write the word here. I'll write garden here. I'll put this in blue. This is my garden. And my lawn, I'll write that in green. Remember, the lawn is this whole area here. The garden's here, and the two together make up the whole backyard. So the whole backyard is this whole rectangle here. So if I say the area of the backyard, backyard. Let me reword that a little bit. Let me think this through for a second. Yeah, let's keep it that way. I got to think these through too sometimes. So we have the area of backyard. Let's think this through, backyard. So if I take the whole area of the backyard and I get rid of the garden, I subtract the garden minus area garden. I'll put that in blue to keep it color coded. Minus area garden. What will that give us? That's going to equal what? Well, that'll equal the area of the lawn. And that's why I'm color coding this. So I hope that makes sense to you. This is kind of how I'm analyzing this. If I take the area of the whole backyard right here, I subtract from right here. Let me actually, you know what? Let me put the subtraction sign in red so you're clear that we're subtracting that out. So I subtract out, take the area of the whole backyard, and I subtract out in red. I minus out the area of the garden. I get rid of it. That'll equal the area of the lawn here, because that's all that'll be left if I take out the garden. And now I just need to figure out the area of all this. Remember, the area is right here. It's length times width. So let's figure this out. What would the area of the backyard be of this whole thing? Well, I'd take the length, 100, times the width, times 80. It's the length times the width. I'll put that in parentheses to make it easier to read. Then we need to subtract out, right here's my subtraction sign. I'll make it a little bigger so you can see it. We need to subtract out the area of the garden. And the area of the garden is the length times the width. So it's 60 times 60. So the area of the garden is 60 times 60. I'll put that in parentheses to make it easier to read. And that's going to equal the area of the lawn. I'm not going to rewrite the area of the lawn. I'll just bring it down. So once I figure this out, I'm done. I'll have the area of the lawn. So let's go 100 times 80. You'll probably have access to a calculator here, but that's going to give us 8,000 minus the area of the garden, which is 60 times 60, which is 3,600. I messed up my color coding. This should be in black. Let me keep it consistent. This was 8,000. And now it's in blue. I'll get it together here. There we go. All right, so I multiplied these two together. I got 8,000 minus 60 times 60 is 3,600. And whatever this equals when I subtract will be the area of the lawn. And if you do that on a calculator, you will get 4,400. You can trust me on that. So when you subtract 8,000 minus 3,600, you will get the area of the lawn, which is 4,400, which is A. Right there. Let's go to the next question. 3 more to go. It says Greg installed a circular drain that has a diameter of 4.8 inches. To the nearest tenth of an inch, what is the circumference of the drain? Again, here we go. Highlight this question. We want to know what the circumference is. So these numbers here represent the circumference. Let's see, I'll write it kind of slanted so I can fit it in here. So this means like the circumference is 7.5 inches and so on. And hopefully you remember that circumference is really the perimeter of a circle, okay? It's the distance around the circle. It's like the perimeter of the circle. So on the test, if you see the word circumference, when you click on your formula sheet, look under perimeter. Then under perimeter, you'll find the word circumference, and this will pop up. Something similar to this, and it says what pi is equal to, and it gives you 2 formulas here. It gives you this formula, C equals 2 pi r, or this formula, C equals pi d, and pi is about 3.14. Now, you need to decide which formula is more convenient to use. They both work every time, but I think the following. If the radius is given, because that's an r right there, the radius is given, I use this formula. If the diameter is given, I use the second formula. So hopefully you remember that in a circle, just let's do a quick review here. In a circle, the diameter is the distance from edge to edge, and it goes through the center. And sometimes they mark off the diameter like this. They mark it off like this. That's what they're doing in this problem. Well, if you think about it, this length would be the same as this length. And then the radius is just half the diameter. The radius is the distance from here to here, or the distance from here to here. Same thing. So based on this little diagram, what do you think that 4.8 represents? The diameter or the radius? Well, it goes all the way across here, so this would be the diameter. So the diameter equals 4.8 inches. And again, you can kind of transfer that diameter down here. You can transfer this segment down here, same length. So remember, the diameter goes all the way across, so it's 4.8 inches. Now, I'm going to bump this diameter up. Watch, I'm going to do some ballparking here. I'm going to say that the diameter, instead of being 4.8, what is 4.8 real close to? What's 4.8 real close to? If I had 4.8, and you can tack a 0 onto this, it doesn't change anything. Let's pretend this is money. Isn't $4.80 real close to $5? Yeah, it's real close to $5. So I'm going to say the diameter is about 5. Okay, and again, since I know the diameter, I'm going to use this formula here, this one here, because this one has the diameter in it. So if they were to give you the radius, you would use this formula. So here's what I'm going to do. This formula says C, I'll write it over here. I'll bring this one down. C equals pi times D. Now, watch how I ballpark this to make it much easier. So C is the circumference. That's the distance around the circle. And I should probably put this in I put this as a capital D. This is a small d. Same thing. I'll keep it consistent. I'll put this as a small d right here and right here. And D represents the diameter right here. And it's 4.8. I bumped it to 5. So let's go ahead and figure this out. Now it says you can do this all on the calculator, but it says pi is 3.14, right? Right up here it's about 3.14. Well, I can bump that down, right? It says pi is 3.14. If this were money, that would be $3.14, right? If it were money, which is real close to $3. So just bump the pi down to 3. Just say it's about 3. So pi is about 3 times, that's a times sign. Let me bring that up just a little bit so it doesn't look like a decimal. Times the diameter. Well, I bumped that to about 5, so the diameter is about 5. Well, what's 3 times 5? That's 15. So the circumference is about 15, which one's closest to 15? It's B, right here. And you're done. I mean, if you get fast at these, you can do this problem really quick. Now, really quickly, you can use the exact numbers. I want to make sure, because some people don't like to ballpark. They like to use the exact answers, but the ballparking makes it go so much quicker. But you could do it this way. Let me just clear all this out real quick to clean it up. If you don't like to ballpark, this was the formula, C equals pi d. And you could say the circumference equals pi. Just bring your pi symbol down times a d, which was 4.8. So just multiply pi times 4.8. And that would give you, well, watch. I've got my calculator right here. You can just punch it into your calculator. I can bring this over. I think I can. Watch. Pi times 4.8. You got a pi symbol right here. So you can go pi times, I think it was 4.8, was it? Yeah, it was pi times 4.8. Do you want to do it that way? That gives you about 15 as well. Let's do that one more time. Here's my pi symbol. Pi times 4.8. And that gives you 15 as well. Remember, I'm just using this formula. It says pi times diameter. You can even use the number 3.14 if you want to. You go, instead of using pi, just use 3.14 times the diameter, 4.8. And you get about 15 as well. I like the ballparking method. So again, I kind of showed you 3 different ways to do this problem. Remember, I used this formula because the diameter was given, and all I'm really doing to find the circumference is taking pi times the diameter right here. Let's go to the next one. It says the foundation of a building is in the shape of a rectangle with a length of 20 meters and a width of 18 meters. To the nearest meter, what is the distance from the top left corner of the foundation to the bottom right corner? Highlight the final question right here. What is the distance? So distance is length. What is the distance from the top left corner? So here's the top left corner right here. What is the distance from the top left corner of the foundation to the bottom right corner, which is right here? So I want to find this length. That's what distance means in this problem, length. And what I see here is a right triangle right here. And I'm looking for the length. Whenever you have a right triangle, that's what this little symbol means right here. It means that the angle measure, this angle measure here, this angle measure right here is 90 degrees. So whenever you have a right triangle, an angle that measures 90 degrees, and you have the length of 2 sides, and you're looking for the length of the third side or the distance of the third side, you use the Pythagorean theorem. And you'll have access to this formula, or on the formula sheet, it'll say Pythagorean theorem, and it'll be under algebra. I'm pretty sure it's under algebra. You just need to look for Pythagorean theorem. Now, watch how I'm going to break this down. How I do this problem here. What I'm going to do, and by the way, this works with triangles that are 90 degrees. They have to be 90 degrees. So I have this right triangle. I'm just going to say to myself, if this length is 18, this length over here has to be 18. I'm not really worried about the meters here. And I'm looking for this length here. That's what these represent, the length of this. So I have a right triangle right here. I'm going to copy just this piece of the triangle, this piece here, over to the right so this other triangle doesn't confuse me. So watch how I do this. Just copy that right triangle over. Looks something like this. It's not going to be perfect. I'm just copying this piece over. This is 18. This length is 20. And I'm looking for this length right here. This is my question mark. Not the prettiest triangle, but in a right triangle, let me stop real quick. Make sure you got that this triangle is identical to this one. You don't have to do this. I just don't want this piece here throwing me off. Now, in a right triangle, there's 3 sides. The longest side is usually pretty obvious to see. Hopefully you can see that this is my longest side. I always call my longest side C in a right triangle. So I'm going to call this C right here. Hopefully you can see that this side is the longest and then these two are a little bit shorter. Another way to identify the longest side in a right triangle is just look across from the right angle. This is my right angle. And the side directly across from it will always be the longest side. And I always call my longest side C. My other 2 sides I call A and B. It doesn't matter. You can call this A or this A, but I usually call my shortest side A. So I'll call this side A, and I call my next, well, actually, this is my shortest side. My bad. Getting ahead of myself. This is my, actually, my drawing's pretty bad. Let me do this a little better. I'm sorry. The way I have it set up, it looks like this is shorter than this, but this is 20. That sure doesn't help. So let me just fix my figure here. And sometimes I'm glad I make mistakes like this. It's important for you to see. I know it makes my video a little bit longer, which isn't great, but I got to work through these things just like you do. I've been doing this for a while. When I first learned this stuff kind of scared me a little bit, I tell you. So let's set it up so it's a little better here. Let's do it like this. I want enough room here. Let's do it like this. So this is my longest, my second to longest side, my kind of shortest side right here. I'll make this a little longer. There we go. Bingo. Okay, this is my longest side. I call that C. This was 20. I'll call that B. And this was 18. I'll call this A. And again, you don't even need to do all this. If you can just look off this figure. So here's how I usually do it. My longest side is C. I always call my, well, not always, but I like to call my shortest side A and my next shortest side B. But you can mix up the A and the B. If you call this B and this A, that's perfectly okay. Just make sure your longest side, which is actually called your hypotenuse, is called C. And then I just plug these numbers into the formula. So here's the formula. It's A squared. I'll rewrite it over here. Plus B squared equals C squared. So my A is 18. So I replace this A with 18. And I square it. Now I'm going to put parentheses around there to make it easier to read. So I replace the A with this. Now again, if you call this B and call this A, and you put 20 in for A, it's okay. Wouldn't mess things up. Plus B squared. What's the length of B the way I set it up? Well, that's 20. So I'll replace the B with 20. Equals, I'll bring down my equals, C squared, this length right here. And once I solve for C, I'm done. So we got to do 18 squared plus 20 squared. So let's do that. Let's bring up our calculator again. Got it over here. Let's clear this stuff out here. Let's do the 18 squared. 18. And here's your squared button right here. Just click this. It squares it and hit enter. It's 324. So I'll write 324 right here. Plus 20 squared, or B squared, which is 400, but I'll do it for you for practice. So 20 squared, just for practice, you take the 20 And here's your squared button. It should be 400. I'll hit enter. It's 400. So 20 squared is 400 equals c squared. And then we add these together. 324 plus 400 is 724 equals c squared. Now, the last step is a little tricky. Whenever you see a square, I'm actually going to erase this right here. I need a little more space. Whenever you see a square, to undo a square, just like how do you undo addition? That's subtraction. How do you undo division? That's multiplication. To undo a square, you do a square root. So to get rid of this square, I'll take the square root. What you do to one side, you do to the other. So whenever you have a square and a square root, they eliminate each other. They cancel each other out. And you're left with c. You're left with c. But you now have to take the square root of 724. Let's do that on the calculator. So what I'm going to do here is take the square root of 724, and I'll be finished with this. So watch. Here's my square root symbol. It's right above the x squared. To access the symbols above the buttons, you hit the second button here first. Hit this first. This will allow you to access all the symbols above the button. So I hit second, then I hit this x squared, and this will pop up my square root right here. Watch, boom. So second x squared, and then type in 724. Hit enter. And you get something funny here, which might happen on your calculator. You're like, what the heck is that? 2 square root 81. If this happens, don't worry about it. Just hit your toggle button right here. Hit this toggle button. It'll switch it to a number. So important. I'm glad this happened. Hit your toggle button. Boom. One time and wait. I hit this, and it changed it to about 26.9, which is close to 27. So I'm just going to write 26.9. I'm going to drop off everything after the 9. So 26.9. Forget the rest of it. So my answer after I solve this is 26.9. Well, if I bump that up, it's closest to B, 27. Right? 26.9 is closest to 27. The rest are gone. And that's the answer. So a lot there. I kind of messed up along the way. That's all good. Hope this made sense to you. Let's go to the final question. It says a sphere has a radius of 7.5 centimeters to the nearest cubic centimeter. What is the volume of the sphere? So let's highlight the final question again. And you probably get tired of me saying that, but it's so important to read that final question because now it tells us what our answer choices represent. It says to the nearest cubic centimeter, what is the volume of the sphere? So this represents the volume of the sphere. What you'll do on your formula sheet is you'll just look for volume and sphere, and you'll see this formula. It's V equals 4/3 pi r cubed. I'll write that bigger so you can see it. It means 4/3 times pi times the radius cubed. This is the formula. It's a scary looking formula for the volume of a sphere. And now it just boils down to us getting the right numbers in there. You know what? Let me write the formula over here. Volume equals 4/3 times pi times r cubed. And I'm putting in these times signs. There's time signs here. They're little ninja time signs. They don't like to... They hide out. Put them back in there so you know we're multiplying. And I'm not going to ballpark this. I'm going to use the calculator for this one because of this fraction. So let's just plug in our numbers. So V represents volume. Bring down your 4/3. Bring down your time sign. Bring down your pi symbol. Bring down your time sign. And now I need to figure out what the radius is. That's really the only thing I need to substitute in for. You could replace the pi with 3.14. But you don't have to. You have this symbol on your calculator. So what's the radius of this sphere? Remember, the radius is the distance, just as a refresher, from the center to the edge. This is the radius. The diameter is all the way across. The diameter is the whole thing. D's the whole thing. all the way across. It touches edge to edge. It goes through the center. The radius is just halfway. It's just this piece right here. Let me put it back in green. Well, this is nice. They give us the radius, right? They give it to us right here. The radius is the distance from the center to the edge. So we know that the radius is 7.5. Right? It tells us right here. Radius is 7.5. That's given. Again, the radius is the distance from the center to the edge. So I just replace this r with 7.5. And I'm going to put parentheses to make it easier to read. So let's replace that r with 7.5 right here. And bring down your cube. And punch this into the calculator and you're finished. So let's bring up the calculator. I'll clear this out. Let's do this. So actually, before I do that, we're punching in just this side, right? We're just punching this in right here into the calculator. The 4/3 times pi times 7.5 cubed. Just that piece there. So let's do that. So this side right here, 4/3. Here's how you enter your fraction. Type in 4. Your fraction button's right here. It says n divided by d. It's right here. So just click on that and it'll turn it into a fraction, and you want the 3 on the bottom, so put a 3 on the bottom. Now the cursor is blinking right here. It's blinking right here. I don't want it at the bottom. I want it to go to its normal position. So just hit the right arrow right here. Just click on that. There you go. And then enter your pi. Remember, this is all multiplication, so enter times next. Then enter your pi, which is 3.14, but you have the pi symbol here, so just hit pi right there. It's right there. Times. Now this 7.5, you don't need to include the parentheses. It's up to you. I'm going to, but you don't have to. You can just put in 7.5 cubed. I'm going to put in the parentheses. So here's one parenthesis. And that's one parenthesis. I hit that, then I put 7.5. I close the parenthesis. And then I want to cube it. So I hit this button right here. This little caret symbol right here. This up arrow. Hit that. And then hit a 3. And then you'll hit enter. Now remember, if you don't put these parentheses in, if you just have 4/3 times pi times 7.5 cubed without the parentheses, that's perfectly okay. Hit enter. And it's about 1767. I'm dropping off all the decimals. 1767. 1767. Let me make sure I did that. I said that correctly. So it's 1767. I'm dropping off all these decimals. 1767 is the volume. So the volume equals 1767. Well, they have 1766. That's okay. I mean, we're going to be a little off due to rounding stuff, but obviously this is closest to C. And that's my answer, and I am finished. Well, thanks for watching this video, and I hope this helped you with the geometry part of the GED math test. Have a great day.